Therefore, what? So interestingly enough, Darius's example of 2n factorial is somehow, man, this feels wrong to me. I wanted this to diverge. I just argued myself into saying it diverges by the nth term test, and yet I got this ratio calculation. I would love for you guys to show me my error, because I feel like this is wrong. Something I've said is wrong. The nth term test comment is wrong, or something in here is wrong. One of those two things has to be wrong. We can't have it converges and diverges at the same time. You've got to make a choice.
There's no relativism in this, right?
There's no independence in mathematics. Like, I mean, we have linear independence, but like you can't be in like an independent. You gotta be a Republican or a Democrat. Oh, that seems like awful. No, let's not make math that. No.
That's what football's for.
That's what football's for. Go team. Yeah. I don't know.
Well, what was your argument on the nth term test again?
Well, I was thinking that eventually, you know, n to the n. Well, let's see here. N to the n is greater than n factorial, right? And then what's 2n factorial? Oh, I see why I'm wrong. Well, I still don't see why I'm wrong. Sorry. So n to the n over, so that would be, say, n factorial times n plus 1 times n plus 2 dot 2n, you know? I mean, this is an. And I convinced myself that that should go to not go to 0. But now that I say it again, I'm not. Oh, look. So this is n times n times n times n fold times, right? Forget about this. True, but useless. So can you, what is that? I mean, 0, fine. But can I make the denominator smaller and consequently make the fraction bigger in an interesting way? What if I trade every last one of these factors? How many factors are there here? How many are there? There are n of those, right? So what happens? Can I replace each one of those with n to make the fraction larger? I can, right? And you see, when I do that, my thought process, you know, I said you could be bold and argue by the nth term test. You would also be wrong. So there's that. Because the nth term test doesn't, oh, come on. I don't know why I'm doing that. That trash can's very full. It's never going to stay in. It does give me joy to throw it, though. So this cancels that, and we get 1 over n factorial. So then by the squeeze theorem, 1 over n factorial clearly goes to 0 as n goes to infinity, right? As n goes to infinity. And so what does this tell us? This tells us that the limit as n goes to infinity of a sub n equals to 0. What's that mean? It means the nth term test is no help to us here. Which is good, because the ratio test proves that it converges. Even though my intuition said otherwise. My intuition was wrong. 2n factorial is not only Darius's sarcastic answer to my find something bigger than n factorial, which is good. I mean, it's a good retort. But this is also bigger. This also, you know, in the pantheon of functions, you know, this is your Hulk to your Thor or whatever. I mean, I don't know. There you go. I guess we'll find out in November what the proper ranking is there, but unnecessary advertisement for Ragnarok. So what's that?
You know better than 2n factorial?
Yeah, I think I do. Yeah, I think once we start down this path, right. Yeah. Now here's the question is like, how about 2n? How about 2n to the n? What happens with that? I mean, there's lots of flavor options we could start playing with here, but so that's the ratio test. Root test. What is the root test? Hopefully I have time to tell it to you today. I think I do, just barely. The root test, which is our final test, I would say it's our final solution, but that seems wrong. Let's see here. What, too soon? Let's see here. So, root test. So the series an converges absolutely when the limit as n goes to infinity of the nth root of the absolute value of a sub n is less than 1. That's number one. And number two, an diverges when the limit as n goes to infinity of the nth root of the absolute value of an is greater than 1 or infinity. And guess what? When it's 1, it's inconclusive. So there are tons of examples where this is the weapon of choice. Personally, I gravitate towards the ratio test because it's a quirk of my calculus 2 that I was not taught the root test. That is unfortunate. This is quite unfortunate because I should have been taught the root test because it's a good test and it deserves a seat at the table just like any of the others. So here's our example, 5, 6, I don't know. I've lost track. But something like this. Oh, how about 2n to the n over n to the n? Oh, that's too stupid. I think we could do that with algebra. Let me do something more interesting. I think he does e to the 2n over n to the n. That's a pretty good one. N equals 1 to infinity. So here's my a to the n, a sub n. And to use the root test, I'm supposed to look at the nth root of the absolute value an, right? In other words, this is e to the 2n over n to the n to the n to the 1 over n power. So what happens there? Since you guys know your laws of exponents, it's easy, right? So what happens? Downstairs we just get what? N. And upstairs what we get?
E squared.
Yeah. Which goes to what? Yes, it goes to 0. Sorry, all of my ratio and root test examples today have somehow come out to working to 0. This does not have to happen. It just happens for the nicer examples, okay? So sorry about working just nice examples for you today. My bad. Anyway, therefore, the series e to the 2n over n to the n n equals 1 to infinity, converges by root test. So I would say if you see something like n to the n in the problem, maybe the root test is the right tool. If there's a factorial, I kind of think of ratio test, but these are kind of general guidelines. So anyway, again, I'll be here tomorrow. We don't have class, but if you have a homework question you want to ask me, go ahead. It's fine tomorrow. Or in office hours. It's all cool. And then after break, we'll pretty much have the whole next week up until your homework is collected for your homework questions. So I might feel guilty and prove the ratio and root test at some point, but if you keep me busy with homework questions, I won't do it. Yeah. I will fill the silence with proof, so I just warn you. Yeah, go for it.